And I'd like to introduce Bill, KC0FHN. He's the president of the Deep Space Exploration Society, or DSES. And DSES is a Colorado-based nonprofit organization dedicated to practical astronomy and also to education of space science for students and general public and society members. The major project they've been working on is restoring and operating a 60-foot dish antenna for radio astronomy and amateur radio experimenting. The site is located in Kiowa County in Colorado. Since 2009, their volunteer members have been working hard to restore and modernize the antenna and its support facilities. DSES also supports radio astronomy and amateur radio projects with smaller antennas. Bill has behind him about 35 years of computer storage, hardware, and power systems engineering management. And his goal is to make DSES a world-class amateur radio astronomy organization focused on space education, scientific learning, and also have fun doing something unusual. And that's for sure. Bill will provide us with the details of the dish's story, its uses, and perhaps some more future opportunities for EME. So with that, Bill, I'd like you to take over and share your screen.
Okay, very good. You'll have to give me the share and we'll do it. It says I'm disabled. So you'll have to unshare yours and there we go. All right, very good. Okay, can you see that?
Yes, sir.
Yes. And that should be a full screen, I think. Okay, we're DSES, and what I've done here is we didn't have an open house this year. We usually have an open house in August around the Perseid meteor shower, and this year with the virus we weren't able to do it. And so we did this. I put together this virtual open house, and I hope you enjoy it. And then I hope to use it in the future to keep people informed about what we're doing. So, to quote Butch Cassidy and the Sundance Kid, who are those guys? What are we doing down there in Haswell, Colorado? We've got a website that details everything that we're doing. We post everything we do up on this dses.science website. Please don't go to the dses.org website, because that's the old website that we no longer have control of. And we're trying to get that fixed and get a link over to this one, but eventually we'll do that. So, like Paul was saying, our charter for the Deep Space Exploration Society, we're a nonprofit organization, 5013C, and we're dedicated to practical astronomy, space science, and radio education for students, the general public, and our society members. We own and operate a well-built 60-foot radio telescope dish near Haswell, Colorado. Tell you something a little bit about the history of this dish. The twin 60-foot dish parabolic antennas near Boulder and the 60-foot dish in Haswell were originally part of a network of sites built for the National Bureau of Standards, which is now NIST. This was for their Central Radio Propagation Laboratory to study tropospheric scatter propagation sponsored by the Air Force. The antenna sites were located from Colorado to Arkansas. Our Haswell dish is somewhere in the middle. A little bit about the history. The goal of the original study was to compile a standard communication handbook of accurate reference materials so that any group desiring to establish such a communication system anywhere in the world would have the data necessary for the site selection and construction. And the study lasted between 1958 and 1974. The information gathered supported communication systems for the Distant Early Warning Radar, or the DEW line. The dish construction was underway in late 1957, and the Haswell land was apparently leased until the purchase by the government in 1963. And the Haswell site was operated up until about 1974, when it was abandoned and surplused. For those of you that don't know what tropospheric scatter is, if you consider tropospheric scatter as a microwave communication system beyond the horizon, And it was developed in that same time frame I just talked about in the late 1950s through the 1970s. The idea here was to have high-speed microwave communication so they could send data over the links. So if I have a station here, T1, and we have a directed beam up through the horizon into a volume of atmosphere up over the horizon, and the intermediate station, I1 here, has a directed antenna looking back at that same volume of atmosphere. The scatter from the atmospheric particles in the atmosphere, they would be able to pick that up and then rebroadcast it and repeat that around a network. And so that was kind of the idea of what they were doing. As with many of these government programs, little expense was spared to achieve the program goals. For example, the original specification of the 60-foot dish stated the maximum deviation of the surface from a true parabola shape shall be no greater than a quarter inch at any point on its surface. The parabolic reflector is to operate with full precision in winds up to 30 miles an hour and slightly reduced precision in winds of 50 miles an hour. The reflector, when properly secured, shall be capable of withstanding winds of 120 miles an hour with a maximum radial ice formation of 3 inches. So imagine that, 3 inches of ice on the dish, and it'll still stand a 120 mile per hour wind. Now, if you thought about our environment in Haswell, that's not such a far-fetched specification. Here's a picture of Ray Uberecken, who's on the call here, standing in the middle of the dish. There's the hatch to get up into the dish. These poles that you see going up, those are the support poles. Those are made out of a wrapped fiberglass, and they support our feed point at the apex. Here's Ray inspecting the mounting point of one of the feed point poles. If you look at the dish structure, this structure is quite incredible. The dish itself, I've been heard, is rumored to weigh 65 tons. This is made out of 10-inch and 8-inch aluminum pipe that's heliarc welded to government specifications for the entire structure, and that's what gives it that super rigidity and flatness to the parabola, and then also the capability of withstanding those wind loads. So the specification for this antenna, I think I skipped one. Let me back up one. No, that's good. Has a practical frequency range of about 400 megahertz to 2 gigahertz. We could go possibly to 10 gigahertz. Haven't tried that yet, but we know we can easily do 2. Has a diameter 60 feet, an antenna gain at 1 gigahertz of 42.5 dBi. The beam width is 2.6 degrees at 400 hertz or 400 megahertz and 0.8 degrees at 1.2 gigahertz. So when we do EME at 1296, we've got a beam width of about 0.8 degrees, which is just right to pretty much illuminate the entire moon. Has low noise temperature, it's full hemisphere coverage, and has a pretty fast slew rate of 40 degrees per minute. Tell you a little bit about the organization history. The organization was originally formed in 1991 in Boulder County. The members started to restore the twin 60-foot parabolic dish antennas at the T22 site on Table Mountain, about 10 miles north of Boulder. There was considerable success for this facility using the talents of professionals and university students in the area. Unfortunately, Table Mountain is a secure government research site, and after 9/11, more conservative management closed the site to amateur use. The DSES needed to find a new home. And that brings us to Haswell. The Haswell site lay dormant from 1974 to 2009. It fell prey to the elements, vandalism, and theft of much of the infrastructure of copper. The original large 3-phase overhead power lines were removed to better facilitate farming around the area. Sometimes during this long period, Paul Plishner, a prominent radio and radar contractor, purchased the site from government auction. Probably realizing the impracticality of restoring the site, he offered it up for sale for several years but found no buyers. And when the DSES group had to leave the Table Mountain site, they asked Mr. Plishner if they could be the custodians of the Haswell site and do some restoration. He agreed, and they moved an operations and communications trailer and some of their equipment to Haswell. I'm going to stop there. Any questions so far? Okay, here's a picture of the site in 1972. Not only did they do tropospheric scatter studies at the site, they did VHF studies at the site and other radio studies, and this 500-foot tall tower was part of that. There's also three-phase 900 amp service at the site with these towers in the background. That's all been taken out now, and that tower is missing. So in 2009, the member volunteers, they've been working since then to restore and modernize the antenna and its support facilities. After making some progress on this restoration, the group president asked Paul Plishner if he would consider donating the dish to the DSES organization, and he did. And so for this generous donation, the site was named the Paul Plishner Radio Astronomy and Space Sciences Center. Mr. Plishner passed away in November of 2016, but his generosity is still greatly appreciated by the organization, and his legacy will live on for many years as the site is brought to full operational status as a science discovery and educational center. Because the site had no power, we had to do solar energy for the electronic sensors, computers, the lights, the sump pumps in the bunker. We had battery arrays and a number of different solar power systems. Between the bunker and the communication trailer is about 600 feet. So there's multiple solar power systems along the way. Ed Korn, Steve Plock, Michael Lowe, and a lot of others spent many long hours installing electrical wiring and fittings to make the site operational. When the dish movement was required for more power, or more power was needed for power tools, we had a 25 kilowatt propane generator available. So you can see the propane generator was installed in 2013, and in 2015 we trenched the entire 600 feet of the site and laid in the 4 strands of triple-aught cable, Ethernet cables, control lines, and coaxial cables. In 2018, Script Creeley, a prominent RF entrepreneur, generously donated the money to bring the single-phase power line over a mile to the site. Once this was attached, we had abundant 230-volt split-phase power, and we could spend less time maintaining solar cells, batteries, and generators, and more time on radio experiments. So thank you, Skip. For some of our accomplishments since taking over the site, we have the solar power systems, the generator, UPS, the electrical infrastructure throughout the facility, utility power restored, emergency telephone installed, internet connection, dish control system, dish celestial and moon tracking system, the antenna feed with fiber optic and coax connections, restroom facilities, underground facilities, the sump pumps for the underground facilities, 14646 talk-in radio and intercom, radio astronomy software-defined radio, itty-bitty telescope for educational purposes, and feed construction for 408, 1420, and 1296 megahertz, and many others. In order to drive the dish, we had to come up with dish motor and drive controls. The group that came down from Boulder found some drive motors and control systems, and they were able to install those and get some stuff working, but we still didn't really have the detailed controllers that drive the dish to a specific location or track an object across the sky as Earth moves. So we had a kind of a runoff between two systems. We had System 1 by one group, led by Dave Moulder and Glenn Davis, and System 2 by the other group, led by Ed Johnson and Ray Ubereken. The System 1 team brought on some software engineers, and they were able to get something to work pretty well. We have both systems working, but we still have a few bugs in the System 2, so we haven't got it installed right now. One of the problems was the Ethernet connection would get lost in the middle, and sometimes it would just take off on us. So we're trying to resolve that. So the dish now is fully capable of doing tracking. And so what I'm going to do is play you a YouTube video, if I can make this work, which it won't. Here we go. And tell me if you can't hear the music on this. That's the other thing I have to do is make my sound work. So did everybody hear the video?
Yep, no problem.
Okay. Yeah, that's courtesy of a new member that we just got, Mark Slover. He's a master photographer, and he has a website on YouTube called Road Trip Ventures. If you want to see some more videos like that, he's an expert in stop motion and that sort of thing. Okay, somebody's got an open mic. Okay, let's talk a little bit about the rest of the facility. We have an underground bunker, what we call the underground. A lot of people don't want us to call it a bunker because they think it's something to hide out in. But in the underground, when Ray went down there, here's Ray, you reckon, in 2014, this is what they found. The whole thing was full of tumbleweeds. It's there again. The tumbleweeds are back. We have to dig all those out of there every year, several times, and before we can get to the door of the underground. When you get in, we've got a pretty large room down there. There's probably about 1,500 square feet of living space down in the bunker. We've got benches, and we've got a tool shop and bathroom and a number of facilities in the underground. One of the problems we have with it is it floods. The ramp going down there where the tumbleweeds were, someone took out all of the, during that time that the site lay dormant, someone stole all of the bricks, the cinder block bricks that were holding back the hillside. And so now the hillside wants to erode, and the mud runs down under the door and into our facility. So what the guys did was started building a new wall to hold back all of that mud, and that's what they're doing there. Also, we built an extra hatch in the underground to get out of in case we had a fire in the front, and that's got a spiral staircase that was built by Ed Cornesteve Block to get out of there. Let's talk a little bit about feed antennas. We've got the big dish, but then how do you drive the big dish? So Ray has kind of been our feed guy. Ray and Steve. And there's Ray there smiling up on the tower. Here we've got a feed for 408 megahertz that we do pulsar work with. And this other feed is for 1290, I believe it's the 1296 or the 1420 feed for doing either trophostatic or for doing hydrogen line. There on the table is one of the feed antennas with the mounting system that Ray devised. It's a quick release mounting system that we can change the feed out in about, maybe half an hour if we got 2 people on the tower. There's some more of the feeds there showing some of Ray's ingenuity. This one's made out of a dog dish and a cake pan. Ray, if you're out there, maybe you could tell us what is the frequency of that feed. This other little one is a 5 gigahertz feed that we're going to use to acquire geosynchronous satellites so we can align the dish perfectly to the known position of geosync satellite. And then this other picture shows the 408 Yagi type feed looking down into the dish. And I don't know if you can see that, but there's a wire mesh on the structure, and then the dipoles are out here in front of that wire mesh. And what I'm going to do is I'm going to play a video that shows what it takes to change out a feed. Let's see if I can do this. Maybe. Give me just a second. There we go. Okay. We'll get a kick out of this. So there you can see, that's Ray Uberekin. He's up on the tower. He's in a climbing harness, and that's Floyd Glick there helping him. And Ray straps on right there to a turnbuckle on the tower, and he walks around and gets in front of the feed. While we're here, you can kind of see the whole facility. This is the generator shack there down the middle and a propane tank. And then that building material down there is where the bunker is. That's 600 feet from where the red truck is down to the communication trailer. All these people standing around on the bottom are there to pick up Ray after he falls off of this tower. Surprisingly, the structure is so strong that even with it sticking out this far, it's about 35 feet off of the access point, you can hardly move that at all. You get almost no deflection while you're hanging onto that thing. And if you fell, it would just support you there. Ray said when he was up there, he says, I was doing pretty good until that swarm of bees came up off of my left shoulder, and that kind of distracted me a little bit. It was hard to work. But that's what the drone sounds like when you're up there, is a swarm of bees. It's pretty windy this day. You notice the little thing coming in to the left side of the screen. That's the landing foot of the drone coming into view, because the camera is gyro stabilized, but the wind is blowing the drone around pretty dramatically. And so the foot of the drone keeps showing up in the video. Okay. So for radio astronomy, we can do, we've got the high gain 60-foot dish. We can do hydrogen line, which is at 1.42 gigahertz. We've got a radio Jove receiver, which does natural radio signals from Jupiter. And as Io rotates around Jupiter, it creates radio signals. That's in the 15 megahertz to 22 megahertz band. Super SIDS, which is sudden ionospheric disturbance, monitor shows significant solar flares and events. That's from 3 to 30 kilohertz. And for SETI, we sit around the hydrogen line at 1.42 gigahertz, and we look for extraterrestrials. Skip is pretty much in charge of that. Steve Plockett and him have been working on that project, and they've got a lot of simultaneous synchronized signal detections from Green Bank, Haswell, and now Skip's new observatory in New Hampshire. Skip wrote a paper called Geographically Spaced Synchronized Signal Detection. And this is what I was just talking about. If you think about a signal received in Haswell from an object and a signal received 1,200 miles away in Green Bank, West Virginia, if you receive a simultaneous signal in those two places, that signal has to originate somewhere outside the orbit of Mars. So it's unlikely that a terrestrial signal or something in Earth orbit would give you a detection of both observatories at the same time. And so that's what Skip is doing here. And he wrote a paper about it for Sarah, and it's called Geographically Spaced Synchronized Signal Detection System. We have this on our website, and you can look it up and read it if you want. It's kind of interesting. We also do H1 or hydrogen line emissions. This occurs when the electron orbiting the nucleus of the atom of hydrogen, after about 10,000 years, the electron flips polarity. And when it does that, a photon is emitted, and that's a little radio signal at 1420.406 megahertz. You don't think that's very big, but there's so much hydrogen out there in the universe that it generates quite a bit of emissions, and we can receive that with this dish, pick it up with a device called a SpectraCyber, which is a very unique receiver that centers around 1420.406, and we can see the Doppler shift of whether that hydrogen that we're measuring is moving towards us or away from us. And that's what the little graph over here shows. The center line is the 1420.406 megahertz, and on either side is a deviation. And so on the right side, it's blue shifted, so it's moving towards us. On the left side, it's red shifted, so it's moving away from us. Or maybe I said that wrong. No, I think that's right. So we see quite a bit of signal strength on this, and we're able to map the neutral hydrogen in the Milky Way, and we can see things. So what we can do with that is we can map the Milky Way galaxy. So this is a map that Rich made with amplitude in color versus the galactic longitude and galactic latitude for the hydrogen signal. Let me move on to pulsar detection. Incidentally, on that hydrogen signal, one of the things Rich has done with this is he's actually taken that to the next level mathematically, and was able to derive the mass of the Milky Way galaxy from the Doppler shift of the galaxy arms that can be detected with this method. And so that's quite interesting, and he was within 5% of the professional measurement. Any questions on that before I move on? Okay. Okay, here's the setup for detecting pulsars. Pulsars are neutron stars that are rotating and generate massive magnetic fields that generate radio signals. And so we can detect pulsars in a broad band of frequencies. We chose around the 408 megahertz frequency for our antenna system to do pulsars. You can detect them across a pretty broad range of frequencies, but this is our setup. So we have a tracking computer. We have a computer that is measuring the amplitude coming from the receiver, and we have a computer that is doing the post-processing, and then a computer that's doing all of our side calculations to figure out what to look at next. I'm going to play a real quick item here on what it looks like to do a pulsar detection, if I can get this to work.
Hey, we got it.
You got it? Where? Look, right there. Oh, wow, that's fantastic.
Yay! This is B 1508 plus 55.
New pulsar.
Yep.
September 12th, 2020. Deep Space Exploration Society Plissner Radio Telescope. Excellent. Way to go. This is number 9.
This is number 9.
Okay, I hope you were able to hear that. So that's kind of what it's like to detect one. We can't hear it, but what we do is the software programs, as you can see here, they fold it. So here's 3 different pulsars. They have different periods: 714 milliseconds, 253, 1187. Those are kind of some of the pulsar frequencies that we see. If we could hear it, you need a larger dish, a cryogenically cooled feed system, and a lot of gain. And if you could hear it, you would, maybe I can play you this video here, and that will show you what it would sound like. We have several on this video. So there you can see there's quite a broad range of pulsars that you can hear. Broad range of different sounds, and that all depends on the frequency, the angle they're coming in at, and some of them even have kind of a double sound.
Bill,
Yeah, go ahead.
yeah, you might want to comment on the size of a pulsar.
Yeah, pulsar, most of these pulsars are quite small, maybe 6 miles in diameter. And these things have the mass of maybe 10 suns. So if you think about that density, if you stood on the surface of a pulsar, you'd be squished flat into a glob of glue, and then you'd be spread out to an infinitesimally thin sheet. If you want to know more about pulsars, there's a YouTube here. This guy, when we put up the video, you can take a look at it. But he describes that, and one of the most dense objects in the universe, and the only thing denser might be a black hole.
Bill?
Yep.
Does the pulse spacing vary in time, or is it constant?
It actually varies in time. As the pulsar decays, it's giving off energy. And as it gives off energy, it has to slow down. So over time, they slow down. But sometimes they're with a companion star. They're in a binary. And they siphon material off of the binary star in order to maintain their momentum. They speed up. So sometimes they speed up if they're with a companion star, but they actually do slow down, and that rate of decay is measurable and can tell you the age of the pulsar.
Thank you.
Let's talk a little bit about amateur radio. We can do tropospheric scatter, communication of microwave over long distances over the horizon, EME moon bounce, 1296. We do HF radio, VHF, UHF, microwave radio, and I think we're working on something beyond 1296 right now, probably 2204. So we have quite the range of radio capability. Right now, we're not doing too much 6 meter, unfortunately, for the group. But we do have that capability. We could do it. Here's our radio station. The radio station is called K0PRT after Paul Plishner Radio Telescope, or the Plishner Radio Telescope. We have a tip-down tower that Ed Korn built for us. It works really well, and we need it to work really well because we have a beam here that's not very strong, and the winds out there in Haswell are ferocious. And this beam, often the beams get twisted on the main structure, and we have to let the antenna down and straighten it. That long stick on the top is the 440 stick for our talk-in radio. And we have that on all the time, whether we're there or not. If you're in the area and you call on 446 and somebody's in one of the facilities along the way there, they'll answer you back on the telephone. We also have a 4-band vertical out there near the tower, and we use that quite a bit. Gary Agronaut is the main operator out there, but everybody can use it. This is the radio station down in the bunker, and we have quite the capability, and we've participated in a number of special events and contests. Let's talk a little bit about EME. To do EME, we have to climb the scaffold. They put the 1296 feed on the feed point. Flipped it off. We have quite a bit of equipment. There's a 200 watt amplifier at the feed point. There's a 20 dB amplifier for the receive side in the feed point. Set of relays that transfers from transmit to receive, so we don't burn out our amplifier. And we use a ASU receiver for 1296 down in the shack. We've got the computers tracking the moon there, and that's what it's all set up to be. I'm going to play you a video of, let's do one where I'm going to play two. One is Myron, and just talking without too much Doppler shift so he can hear his own echo, and we're going to play that one.
CQ, K0 Papa, Radio Tango, Delta Mike 88, Colorado.
You got somebody?
No. Hello CQ, CQ, K0 Papa, Radio Tango, K0 PRT, K0 Papa, Radio Tango, Delta Mike 88, Colorado, over.
You know, there you can see that he's actually hearing his own echo at the speed of light to the moon and back, about 2.5 seconds. And that's quite exciting when you first do that. Here, I'm going to play another video here where Gary's doing a QSO with one of the stations in California. I'm going to get out of this one in a minute. This shows you the echo as well. Let me play the right one here. Here's the one with the single sideband point off.
Whiskey 6 Yankee X-ray, Whiskey 6 Yankee X-ray, Kilowatt 0 Papa, Radio Tango. Kilo 0 Papa, Radio Tango. Whiskey 6 Yankee X-ray, Kilowatt 0 Papa, Radio Tango. Kilowatt 0 Papa, Radio Tango. Roger, copy your Charlie Mike 87, your Charlie Mike 87. We are at Delta Mike 88, Delta Mike 88, Delta Mike 88, and I read you 5x4, 5x4 in southeast Colorado, Whiskey 6 Yankee X-ray, kilowatt 0 Papa, Radio Tango. How copy?
I would say 5x5. 5x5. 5x5 here. How much power are you running? How much power are you guys running?
Roger, we're running 200 watts, 200 watts with a 60-foot dish antenna, 60-foot dish antenna. We are a restored radio telescope site in southeast Colorado. That's 200 watts with a 60-foot dish antenna. How copy?
Very good. It's sounding very good tonight. We're running here 400 watts and 28 foot dish at 400 watts. Over.
I'm going to truncate that for time, but you kind of get the idea there that off the moon, we're single sideband and running 200 watts, and he's reading us 5x5. I think Skip could verify that because we also had a QSO with Skip up in Alberta, and he read us very well up there too. Okay, let me jump to education and outreach. We hold an annual open house usually in August with the Perseid meteor shower. Sometimes that doesn't work out too well because it doesn't fall on a weekend. We do optical radio astronomy demonstrations, the Pikes Peak Science Fair, publications on radio and radio astronomy, Society for Amateur Radio Astronomers, site trips to national radio observatories, website with all the proceedings and articles open to the public, and membership of student participants. Show you a little bit about that. Here's some pictures from our annual August open house, where we're doing some optical solar astronomy. We're demonstrating the itty bitty telescope made from a Dish Network dish. We usually feed everybody breakfast when they come out, and everybody sits around and talks about ham radio and radio astronomy and has a good time. In education, we sponsor some special awards in the Pikes Peak Regional Science Fair. Last year, we had a student that we mentored a little bit, but he pretty much took it and ran with it, took some of our data set for hydrogen line and wrote a paper about it and presented a science fair project on it. He went to state competition and won a number of awards. Xander Duvall. In the 2019 Sarah Western Conference, we had a young man, Hans Gainsborough, that gave a presentation on a modified SDR radio, and he did such a great job on that he got a standing ovation from all of these senior radio astronomers. Was there a question out there? I heard somebody come in. Okay, and Dr. Rich Russell, when we had the open house, he set up an extensive radio astronomy education certification program. I'd like to also say that that Rich also does a lot of education during our science meetings. We have a science meeting once a month, and Rich usually presents a good science paper at that, and everybody learns something. We also do a lot of public outreach. Gary Agronaut and myself have been going to Haswell and Eads in the local area and giving presentations to the locals. We want to do this mainly because a lot of them are wondering what we're doing down there. And so we want to make sure that we're open and transparent about everything that we do so that they don't wonder, and it also kind of protects our site. We also do outreach with the Society of Amateur Radio Astronomers and participate quite extensively in that group. So that's about all I have. We have meetings The engineering operations meeting meets every second Monday of the month at 5:30 Mountain Time. The science meeting is every fourth Monday of the month at 5:30 Mountain Time. Our site work trip our standing schedule is every third Saturday, leaving the Ellicott Fire Station at 7:30. But we always have to watch the website and watch the communication for that because the weather can change it, and also people's schedules change it. So we do a number of site trips. Lately, it's been more than one a month, but we often go to the site and do work. The site's about 2.5 hours from Colorado Springs. You can join the DSES for $50 a year for full voting membership, or you can join by PayPal on our website, dses.science. And that's all I've got. I'll open it up for questions. Thank you.
Hey, Bill, what are you going to be doing that 2304 stuff?
I don't know. I think that we're going to have to build the feed. I think Ray, is Ray on? I think he has already built a 2304 feed or 2204. The 22 or 22. Go ahead, Ray.
Okay, we don't have the feed done yet, but the transverter or the complete station was, I tested that this evening before this meeting, and it's working fine. And so we're getting about 60 watts output out of the receiver or the transceiver. Basically, that's the way we'll use it, as a transceiver. And it'll be mounted right up at the feed as GAN. So we'll have about 60 watts on 2304 and a very low noise figure. So we should do moon bounce very well. And we'll do that for sure this next coming September, but probably in between, we'll even put the feed up there and try it sometime to just test it out.
Bill, is your funding supplied by the membership only?
Pretty much. Yeah, once in a while we'll get a big donation, like when we got the power line donation. Lauren Libby, one of our members, donated the money for our propane. We were running off the generator. So we have a few large things, but most of it's just membership fees.
You do
Bill,
fantastic with it.
Bill, does your group have to pay property tax since you're a charity?
We do. We pay the property tax in the Kiowa County on the site, but it's very low because it's zoned as rural farmland basically, and it's not zoned for us as a commercial thing. So we do pay property tax, but it's very low.
About $10 a year.
Yeah, Myron's our treasurer there, and he pays that bill to the property tax.
Has the date been set for the August open house?
We'll have to look at when the Perseid meteor shower is. It kind of floats around there. If it falls in the middle of the week, we'll probably put it on one of the adjacent weekends.
Say, Bill, any idea why, I always wondered this, why did they have a bunker way back when that thing was that way?
Well, two reasons. In the summertime, it's hotter than hell down there. And in the wintertime, it's cold. So the bunker is kind of a neutral place to be. And part of it too was they had a lot of equipment that was on that bench that you saw in that room. And I think the bunker was a good heat sink for a lot of that heavy transmitting equipment. Just dissipated it into the walls of the bunker, and it kept it cool in the summer.
Yeah, Bill, they also lived in that all the time. They had showers and a galley down there as well.
That's true. Yeah. And we kind of do that too. There's a bathroom down there. We just have a porta-john because we haven't taken the time to rework the septic system. There is a septic system, but we haven't reworked it. There was a massive cistern for water, and that's still there. We don't use that water. We use our own cisterns. We have plastic, those 500-gallon plastic containers, and we have 3 of them. We have 1,500 gallons of water on site. But it has a little kitchenette and plenty of space to lounge around in. We've got a tool room and a machine room where we've got a bandsaw and a drill press and that sort of thing. So we're pretty capable on site. We're getting more and more tools on site all the time, so we'd have to haul less with us. One of the things about going to the site is you don't want to go down there without everything available to do the work you're going to do, because it's a long way back to get it.
I didn't realize it was so big. You know, I've seen pictures before, but I didn't realize it was that big under there with all those different rooms. So that's interesting.
Yeah.
They sure built it a long ways away from the dish, though, didn't they? Geez, that seems like a long ways.
Yeah, they did. And they actually ran a very large coax from that room, or several of them, all the way up to the dish. So they had 600 feet of this massive coax and multi-strands in a wooden cable lay along the ground. That's kind of been our nemesis now, because that wooden cable lay has deteriorated and rotted to nothing, and all the nails in it are starting to spread out on the ground, and they get on the road. So we have a lot of flat tires.
Yeah, that's not good.
Yeah.
Why would you suppose they needed a 600-foot distance?
I don't know. Ray, do you know why they did that?
Well, remember that the dish was built on the site after it had already become operational for other reasons. And so the tall tower, the 500-foot tower, and the underground bunker were very close to each other in the middle of this big square property. But when they put the dish on, they actually added a little corner to it, another little square on the corner. And so the dish came along after the site was already built.
Ah, that would explain it. They didn't want to build another bunker under the dish. But we don't run it that far. We run about 200 feet from our communication trailer to the top of the dish with coax. So that's pretty short distance compared to what they have.
Yeah, the trailer was a nice find, wasn't it?
Yes. Yeah, that came from where did that come from? The Department of Commerce and the Radio, Telephone, and something Institute. It's an aluminum trailer. Now that's kind of a problem because it gets very hot. It's this aluminum bake box. We've seen we had a remote temperature sensor in there one summer and had it hooked up to the internet, and we could read it from afar as well as some of our experiments. And we saw temperatures in there of 160 degrees.
Good grief.
But now we've got some fans and some exhaust fans and some air conditioners. And so we're trying to keep the temperature in there down so we don't cook our equipment.
Bill, did you say Table Mountain was north of Boulder?
Yeah, it's north of Boulder, about 10 miles straight west of Longmont.
Okay, I was talking to Paul about that earlier. I was under the impression it was either north or south Table Mountain at Golden.
Oh, yeah, there's a South Table Mountain, but it's not that one. It's North Table Mountain.
I learn something every day.
Bill, I was just wondering about the data rates and the bandwidths that you have between the telescope and your computer facilities in the bunker. Make any comment on that?
Well, we only have an Ethernet connection, standard, like 10 meg Ethernet connection between the comm center and the bunker. And so we don't really do any operations on the dish from the bunker, where everything's done in the comm trailer. We do have fiber optic cable to the feed point in the telescope to the comm trailer, and so we can do pretty high speed stuff on fiber optic as well as coaxial cable. We have like a 3/4 inch hardline coaxial cable to the feed point.
Thanks.
Well, that's great, Bill. I really appreciate you taking the time to do this for us tonight. And it's been very interesting. And I'd like to go down there myself sometime when you guys are doing some EME work and at least get to hear my own echo.
Yeah, that's a lot of fun. Yeah, we're open to membership. Anybody wants to join? We do have a lower cost non-voting membership that you can join with. What we're looking for is more and more people to go down and do work. Right now, the organization consists of somewhat, it's variable between 50 and 65 people, but generally there's only about 15 core members that are doing most of the work on the site. And so anybody that wants to join and go to the site and do stuff, you're more than welcome.
Well, that's great.
So, if you want any more data about some of these items like EME and hydrogen line and radio astronomy and all the things we're doing, if you click on that dses.science, we publish everything we do. And so there's archives there of all the meetings, all of the papers that we're writing. There's a lot of information out there on that website.
That's great, Bill. And yeah, I was at, I listened in on one of your science meeting, Zoom meetings, and it was very, very interesting. I learned a lot. Well, thanks very much, Bill, for all your time tonight. And this is being recorded, and we will have it on the group.io in a message probably tomorrow. Thanks again, everybody, for joining us tonight.
Okay,
Thank you all. Nice presentation.
Thanks, Bill. Great.
Okay, thank you.
Yeah, thanks, guys. A lot of fun.